What's up, Banana Republic? It's your boy, BananaJoe808. And today, I wanted to cover 2.2 more functions, specifically how we can use their following graphs to determine the interval in which the function increases, decreases, or remains constant. So let's slip right into it. Here we have our first problem. Number one, a nice little parabola. And so how we determine our intervals is I plot a point on the graph in which the direction changes, and then this is optional, but I draw a line down the middle so I know where the direction of the graph changes or splits off. And so when we answer these, we answer it from left to right. I hope everyone else answers from left to right. I think everyone reads from left to right unless you're from Japan. So I'm looking at this and I notice that it starts from what seems to be forever ago. So I write negative infinity, but it does stop at negative 2. So that's the first half of my answer. Second half would be the right side of my graph. So we start off where we left off at negative 2, and again it seems like it's going on to forever, so I'll put infinity. After you write all this, you want to add the direction in which your graph went. So starting from the left to the right, you notice that our graph went down, decreasing, so our interval was decreasing, and then after that, our interval on the right side was increasing. Pretty cool. This brings us to our next problem. Again, Banana Joe plots the point in which the graph changes, and I draw a nice little line just because. Now, I'm going to read from left to right. Banana Joe notices that the graph is positive infinity because it's going up, but it does stop at 1. That's okay, because it starts again at 1 and it goes on to infinity. Now, Banana Joe, why is the constant infinity? Well, I'll tell you. It's above the x-axis. See how it's all the way over here, not here? So I think that's what makes it infinity instead of negative infinity. So here I'll draw my arrows as to where it goes, just to verify and to show my work. Question number 3. We have a little wonky function action over here, but nothing Banana Joe can't handle. Anyways, we don't need to highlight anything because the graph only goes in one direction, which is this way. So Banana Joe will only draw one point, which is negative 2 onto infinity. Now, where does the direction go, Banana Joe? It goes up. It goes all the way up. It is an infinite. It is increasing. It is not constant, because a constant would look like that. You dig? Moving on to problem number 4. Here we notice that there's more than one change in direction. But that's okay. Banana Joe is an elite math student. So I'll plot the points in which the direction of the graph changes, and I'll just do my problem like how I always do. But I keep in mind with the fact that there are 3 different changes in direction instead of the usual 2. So I'll draw 3 different points for my answers. Starting off with positive infinity, because I see the graph is going up, but it does stop at 0. Not judging, but using our knowledge from previous answers, we know that the next point would start with 0. But it does decrease to 2. With our last point here, we see an increase from 2 onto what seems to be positive infinity, because it just keeps going up, and there's an arrow on it too. So that showcases that it's basically infinite and increasing. Last problem. Banana Joe likes this one. So I'll plot the point that I see. I'll even draw a line on it too. And you could draw a line on this one as well. I just didn't draw one like this because my highlight is kind of bulky. Now, notice how the graphs are aligned. What would you put here? I would put positive infinity, 0. And then 0 to negative infinity. Oh, but Joe, Banana Joe, wouldn't it be like something else? Maybe, but we know there is a horizontal asymptote here, so it would never touch the x-axis. So it would keep decreasing forever and ever, on the right side at least, but it would never touch 0. So we know it's negative infinity. Same with positive infinity. It would have kept going up if it didn't stop at that point. Thank you guys for watching. Banana Joe is very happy. You have just learned how to use the following graphs to determine the interval in which the function increases, decreases, or remains constant. Stay slippery.